Hello dear students, welcome to Puneri Vidyapit. Dear students, from this video we are going to start linear programming session in which we are going to discuss all contents regarding MCA Management 2024 credit pattern syllabus. Now we are going to begin with the introduction of our lecture in which we are going to see about the basic terminologies which we are going to study in linear programming. So starting from beginning, we are going to see some important terminologies in which first of all we are going to see what is operation research. Now operation research, it is an application of scientific models, techniques and tools of operations of system with optimal solution of problem. Now this is also called as OR subject, in which we are further going to deal with linear programming problems. These linear programming problems are most useful in application based, which are mostly used in industrial mathematics. Now the term linear means it is related to the functions which are of order 1. Order 1, which means in this you are going to have the variable power as 1, means you are going to have like this x plus y, means you are not going to get here quadratic or any cubic function over here, right? So you are going to have just linear programs or linear equations, right? So therefore it is a linear programming. Now what is meaning of programming? Then it is nothing but the planning, right? So in which you are going to do resource planning, in which you are going to do sums related to minimizing the cost, maximizing the cost, minimizing the time resources. Next, these are going to be done with some of the objective functions. Now the main aim of objective function is either to maximize or to minimize. Maximize, here we are going to maximize profit. After that we are going to minimize the time resources. So this is called our objective function. Now this objective function is hold or it is dealing with constraints, which is tied with some of the constraints. Those constraints are nothing but the equations on which variables are to be determined. Basically these are the restrictions on LPP. These are the restrictions on linear programming problems. Now these could be in terms of equalities or inequalities. Now what are they? That we are going to see. So basically this is a general LPP problem in which you are going to first get optimizing Z. Now this optimization will either have maximization or minimization problem, in which you are going to get the optimization function which will be based on the variables. Now these variables or these optimization function, that is either maximization or minimization, it will based on constraints, some of the constraints, first constraint, second constraint, it depends question to question. Now there could be many 3 to 4 variables and many number of constraints, so that could be depend. Now if we see what is objective function, then a linear function z, which is equals to c1x plus c2x, c1x1 plus c2x2 up to cnxn, where x is this c1 x1 plus c2 x2 plus up, it will go up to cn xn, that is z equals to summation of j equals to 1 to n cj xj. Now this function can be optimum, that is maximum profit function, or minimizing cost function, as we have discussed already. So such type of function is called objective functions. Now these functions are based on basically variables. So these variables, they are known as decision variables. The variables which are j equals to 1 to n, means x1, x2, x3, x4, these are decision variables on which our objective function depends. Now these definitions are very important for exam perspective. So please remember to have the overview of those definitions, and definitely they would be appear in your exams. Next terminology is constraints. Now what are constraints? They are nothing but the restrictions which we have seen here. This is first restriction, this is second restriction, it will go on. In exam maximum you will get 3 constraints to solve. but it would also get depends on the type of the functions, right? So the set of expression which is in the form of inequalities, that is less than equals to or greater than equals to, or maybe in the form of equalities, which defines the limit in which the solution of the given problem is found. Means these are the constraint in which you are going to get values of your variables, right? And those variables would satisfy the objective function, that is either to maximize or to minimize the cost, maximize profit function or minimize the cost function. Next, non-negative constraint. Now, what is non-negative constraints? Your each inequality or each constraint, it would be a non-negative. Okay, the inequality is xj greater than equals to 0, where j equals from 1 to n, means it would get vary, it will depend upon the number of variables. These are called non-negative constraints. Negative value of decision variable means negative production. Now sometimes you would get the function like this. Sometime you would get the question like this: 2x1 plus 3x2 plus 3x3 suppose, and you get greater than equals to minus 5. Now if here it is minus 5, it is usually a positive value, it is always, it should be a positive value. Then why this question describe it as negative? It would never be negative, you have to make it positive. How could you make it that? You have to just multiply minus 1 on both side, right? You have to multiply minus 1 on both side. If you multiplied minus 1 both side, then definitely your sign also get opposite. Means if this was your sign, then afterwards after multiplying minus 1, it gets less than equals to, means your function would get minus 2x1 minus 3x2 minus 3x3 less than equals to plus 5, right? So always remember your this value should always be positive, and if it's not given positive in question, it means you have to make it positive, right? So further we are basically going to deal with such questions, but for now you have to remember that your your value of your constraint, it is always a non-negative one, right? Next, moving on, basic solutions. Now what are the basic solutions? The real numbers xj's which satisfies non-negative conditions are called basic solutions of LPP. Basic solutions of LPP are basically the values of the those xj's, means those variables, values of those variables which would satisfy the given condition of your constraints, right? So those values are called basic solutions of LPP. Now in that, first is feasible solution. Feasible solution is the real number which satisfies all constraints, right? So some of the solutions would say, means suppose if you have a question, if you have equation 3x plus 2y equals to 6. Now, this question would have many multiple values of x and y. Suppose here is your x, here is your y. So if your x equals to 0, then your y would be equals to 3. If your y equals to 0, your x would be equals to 2, right? So these are the solution for this equation, right? 3x plus 2y equals to 6. These two are the solutions for this equation. Means these solutions are the basic solutions of this equation, right? So these are the basic solutions of the equation. Now you are not going to have one single constraint, you are going to have multiple constraint, and the values which satisfies the constraints, all the constraints, multiple constraints, those values are called nothing but feasible solution. Okay, the real numbers xj's which satisfy all the constraints are called feasible solution of the LPP. I hope you understand the definition of feasible solution. You have to just remember this definition. These are very important definitions. Next is infeasible. Now this would be opposite of feasible solution. The feasible solution was speaking about the values which satisfies all constraints, whereas infeasible solution, it will be speaking about the values which are going to fail to satisfy the constraints, right? Now in that further, there would be next definition, that is basic feasible solution. The real number which satisfies all constraints and non-negative conditions are called basic feasible solution of the LPP. Next definition is optimum solution. Any basic feasible solution which optimizes the objective function, it's called optimum solution of the LPP. Now, the main motto is to find the optimum solution of the LPP. You would get very many different values of your constraints which would satisfy your constraint. You are going to get many different values of your feasible solution. Those feasible solution you have to use in your objective function, and you have to see whether those values maximize or minimize. If your problem is related to maximization, then you have to find the maximum value for your solutions, your basic feasible solution. You have to find the which solution would satisfy the maximum value of which solution would give maximum solution for your optimum solution, right? So those values of x and y, or those values of x1, x2, x3, x4 would be the optimum solution of the LPP. Now, dealing with such solutions, we are going to see using different methods. Those methods could be so simplex method, two-phase method, graphical method. Basically, you don't have in your syllabus, but we will also see that after some point. So first of all, let's deal with one of the question which was in your exam. Just a second. Yeah, this is your April May 2025 question paper, and now you can see over here. Just a second. Yes, you had question related infeasible solution, right? Which was for 2 marks something. Yeah, it was for 2 marks. You had to explain what is infeasible solution. Now in today's lecture we have seen what is infeasible solution. The infeasible solution is proposed set of values for a decision variable that fails to satisfy constraints, right? Now what would be those constraints? What would be those constraints? Constraints are nothing but the restrictions, right? The restrictions which you are going to have to find the solutions for your objective functions. So these are the basic definitions that you need to remember, which would be asked in your question paper in your exams, as we have seen one of the example which is just recent one. So most important is those basic definition. Further we are going to deal with many different concepts, such as in further we are going to see how to make LPP problems. Now first question only deals with same only in your exam question paper. Let's see here. Maybe it was in 2020's pattern, I think. Yeah, but you would also get some of the questions where you have to make your own LPP solution, right? Your own LPP problem, and using those problem you have to solve those problem. Here it is. You are going to get the question in either in the form of table or either in the form of paragraph, and after that you have to make those table or that paragraph in the form of your LPP solution, and then you have to solve. Either you have to solve by two-phase method, simplex method, or many other things. So after that we would just glance through a textbook, what is given in textbook. So this is just a beginning, so it won't be asked in your exam. So but first keep reminding definition of operation research, though it won't be asked, but still for safe hand you have to just remember the definition. After that, what are the things we are going to deal with? Assignment problems, transportation problem. In that starting we are going to start with simplex method. After that, blending problem, machine related problems would be there. PERT CPM would be there. Then after that you are going to also remember the definition of linear programming, right? Linear programming definition, although it won't be asked in exam, but you have to remember that. Then next most important definition, it is objective functions definition, constraints definition, then general LPP form. This would also be asked in exam. After that, basic terminologies in which we have seen objective function, decision variables, constraints, non-negative constraints. These are also most important. So you should remember that too. After that, basic solution, feasible solution, basic feasible solution, optimum solution. These all we have seen today. After that, just add one more definition in this, that is infeasible solution, which was asked in your exam. So this would also be asked again. So that also you have to remember. Advantage, there is no bare minimum chance that it would be asked. Then further applications also bare minimum chance it won't be asked. Next is formulation of LPP, which we are going to see in your next lecture. So this was for today's. For further we are going to see formulation of LPP, and after that we are going to start with our simplex method, which is usually asked in exam, right? So yeah, this question was also there in a last year question paper, 2024 question paper, definition of slack variables, and with that it was surplus variable definition, which we have seen just now in our question paper. Here it is. Yeah, slack variable and surplus variable. So it would be asked in your question paper too. So that we are going to deal with. After that we are going to deal with two-phase simplex method. So this was for today. Till then, goodbye, and share this lecture series among your MCA management 2024 or 2025 credit pattern friends, so who can also get benefit from those lecture. So till then, bye bye.